Basics of resistors, detailed description. A resistor is one of the most common and important electronic components used in almost every electrical and electronic circuit. Its main job is to control or limit the flow of electric current. Without resistors, too much current could flow through a circuit and damage sensitive electronic parts such as LEDs, transistors, microcontrollers, sensors, and integrated circuits, ICs. A resistor converts some of the electrical energy into heat, making it possible to safely control voltage and current in a circuit. The resistance of a resistor is measured in ohms, omega. A higher resistance value allows less current to flow, while a lower resistance value allows more current to pass. The relationship between voltage, current, and resistance is explained by Ohm's law, which states V is equal to I times R, where V is voltage in volts, I is current in amperes, and R is resistance in ohms. From this formula, current can also be calculated as I is equal to VR, and resistance can be calculated as R is equal to VI. The electrical power converted into heat by a resistor is calculated using P is equal to V times I, P is equal to I superscript to R, or P is equal to V superscript to R, where power is measured in watts, W. The images also show how resistors behave in both DC, direct current, and AC, alternating current, circuits. In a DC circuit, such as one powered by a battery, the voltage and current remain constant, so the resistor continuously limits the current flowing through the circuit. In an AC circuit, where the voltage changes direction many times every second, the resistor still opposes the flow of current. However, unlike capacitors and inductors, a resistor does not change the phase of the voltage or current. This means that in a pure resistive AC circuit, the voltage waveform and the current waveform rise and fall together, remaining perfectly in phase. Because of this simple behavior, resistors are widely used in both AC and DC electronic systems. The images further explain that resistors are available in many different types, each designed for a specific purpose. Carbon film resistors are inexpensive and commonly used in general electronic circuits. Metal film resistors provide higher accuracy, lower noise, and better stability, making them suitable for precision circuits such as amplifiers and measurement equipment. Wire-wound resistors are built using resistance wire wound around a ceramic core, allowing them to handle high power and high temperatures, making them useful in motor controllers, power supplies, and industrial equipment. Surface mount device, SMD, resistors are very small resistors designed for automated PCB assembly and are widely used in smartphones, laptops, televisions, automotive electronics, and IoT devices. The second image introduces variable resistors, which allow the resistance value to be adjusted manually. A potentiometer is a rotary variable resistor commonly used to adjust audio volume, brightness, motor speed, and sensor settings. Turning its knob changes the resistance, which changes the output voltage or current. A trimmer, trim pot, is a small adjustable resistor used for calibration and fine adjustment inside electronic equipment. Unlike a potentiometer, it is adjusted only occasionally using a screwdriver during manufacturing or maintenance. The images also describe several special-purpose resistors whose resistance changes according to environmental conditions. A thermistor changes its resistance with temperature and is commonly used for temperature measurement, battery protection, air conditioners, refrigerators, and electronic thermostats. An LDR, light-dependent resistor, changes its resistance depending on the amount of light falling on it. It is used in automatic street lights, solar garden lights, light meters, and camera exposure systems. A varistor, MOV metal oxide varistor, normally has very high resistance, but when a high voltage surge occurs, such as from lightning or switching spikes, its resistance drops quickly to absorb excess energy and protect electronic equipment. Varistors are commonly found in surge protectors, UPS systems, televisions, and power supplies. Another important topic shown in the images is the resistor color code system, which helps identify the resistance value without using printed numbers. Each colored band represents a digit, multiplier, or tolerance. For example, a resistor with brown, black, red, and gold bands represents 1 kΩ plus or minus 5%. Engineers and technicians use these color bands to quickly identify resistor values during circuit assembly and troubleshooting. The images also provide a practical example of using a resistor to protect an LED. Suppose a circuit uses a 12V battery and an LED that requires 2V and 30 mA, 0.03 A. Since the battery voltage is much higher than the LED voltage, a resistor is needed to safely limit the current. Using Ohm's law, the resistor value is calculated as R is equal to 12V to V divided by 0.03 A is equal to 333 ohms. The nearest standard resistor value is 330 ohms, which safely limits the LED current to approximately 30 mA. The resistor power rating is calculated using P is equal to I superscript 2 R is equal to 0.03 superscript 2 times 330 0.3 watt, so a 0.5 watt resistor is recommended to ensure safe operation. Without this resistor, excessive current would flow through the LED, causing it to overheat and fail. In everyday life, resistors are found in almost every electronic device. They are used to limit LED brightness in lamps and indicators, divide voltages in sensor circuits, set the gain of operational amplifiers, pull digital input pins to known logic levels, protect components from excessive current, filter signals with capacitors, generate timing circuits, and control motor speed and electronic loads. They are essential components in televisions, computers, smartphones, chargers, automobiles, industrial control systems, medical equipment, communication devices, and home appliances. In summary, a resistor is a simple but extremely important electronic component that controls the flow of electric current and protects circuits from damage. By selecting the correct resistor type, resistance value, and power rating, electronic circuits can operate safely, efficiently, and reliably. Whether it is a fixed resistor, variable resistor, thermistor, LDR, or varistor, every resistor plays a specific role in modern electronics, making it one of the fundamental building blocks of electrical and electronic engineering.